In Unit 7, Opener number 2, we're going to spend a little bit more time focusing on formulas. This formula here is one that you might recognize. It's one of my favorites, and it's called the quadratic formula. The way that you read it is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. This plus or minus right here is the part of the formula that sometimes gets students a little bit hung up. All that this means is that this is really just two formulas in one. You could rewrite it like x equals opposite b plus the square root of b squared minus 4ac all over 2a, or opposite of b minus the square root of b squared minus 4ac all over 2a. Our first task in number 1a is asking us to take this formula and to solve it for c. My initial thought was that I might want to take one of these two simpler formulas, but I actually think it's going to work out okay if we use our original formula, even though it has that plus or minus in it. I think that something nice will work out when we go to solve the equation. So I'm going to erase these two formulas. I'm going to rewrite my original formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. And we're going to take this formula and we're going to solve it in terms of c. Whenever I see a formula that has a fraction in it, the first thing that I try to do is to get rid of what's in the denominator. What I'm doing is I'm dividing the numerator by 2a, so in order to cancel out the 2a, I need to do the inverse operation of division, which is multiplication. So if I multiply both sides by 2a, that will allow me to cancel out this 2a on the right-hand side. On the left, I'm left with 2ax equals, and then on the right, I'm left with opposite b plus or minus square root of b squared minus 4ac. Since the c is underneath the square root, I'm going to save that part for last, and the next thing that I'm going to try to do is to get rid of this opposite b. You might be confused by the plus or minus right here, but this symbol actually has nothing to do with what we're going to do next. If we want to try to cancel out this b, the only thing that we have to worry about is the sign that comes before it. Since this is a negative sign, if we're trying to cancel it out, we have to do the opposite. So I'm going to add b to the right-hand side, because negative b plus b is going to cancel out. Whenever I do to the right-hand side, I have to make sure that I do to the left-hand side also. So on the left, I have 2ax plus b, and on the right, I have plus or minus the square root of b squared minus 4ac. The next thing that I need to do is to try to eliminate this square root. So I need to think about my inverse operations. The inverse operation of square rooting something is to square something. So I'm going to take this entire right-hand side and I'm going to square it. And since I squared the right-hand side, that means that I also need to square the left-hand side also. Even though the right-hand side is the one that looks a little bit more complicated, it's actually this side on the left that we're going to have to do a little bit more work with. That's 2ax plus b quantity squared. I'll remind you how you need to deal with that side in a moment. On the right-hand side, we have a plus minus. Well, when I square something, whether I have a positive or a negative, if I square it, it automatically becomes positive. So I no longer have to worry about this plus or minus anymore, because whatever I'm doing when I square it, I get a positive result. So the only thing that I have to worry about is the square and the square root undoing each other, and all that I'm left with is what's on the inside of the square root, which is b squared minus 4ac. On the left-hand side, I have a binomial, two terms, squared. To refresh your memory on how to do this, if I'm squaring a binomial, I have to multiply that binomial by itself. So I'm going to rewrite this as 2ax plus b times 2ax plus b. The right-hand side I'm going to leave for now, b squared minus 4ac. On the left-hand side, we have to apply the distributive property, and we have to make sure that we're multiplying every term by every other term. So I'm going to start with 2ax times 2ax, and I get 4a squared x squared. Next, I have 2ax times b, which is 2abx. The order here doesn't really matter, but I'm writing it in alphabetical order so that if I come across a like term later, I'll make sure to notice it so I can combine the like terms. Next, I have b times 2ax, which again is 2abx. So there's some like terms like what I was talking about. Finally, I have b times b, which is b squared. And I can tell right away that that's going to be really convenient because I have a b squared on the right-hand side also. And you'll see in a moment that that means that those two terms will actually end up canceling each other out. Before I get there, though, I'm going to combine these like terms. So I have 4a squared x squared. 2abx plus 2abx is 4abx plus b squared equals b squared minus 4ac. Since I'm isolating the c, I want to get rid of this term right here, this b squared. So I'm going to subtract b squared from both sides. And I see that the b squared does, in fact, then cancel out on both sides. So I'm left with 4a squared x squared plus 4abx equals, and don't forget this sign right here, negative 4ac. After all that, I'm finally almost done. If I want to isolate the c, I see that the negative 4 and the a are both attached to it by multiplication. So I have to do the inverse operation, which is to divide both sides by negative 4a. On the right-hand side, I'm just going to have c left over. On the left-hand side, I'm going to have, and I need to remember to distribute that negative 4a to both of these terms. So if I start with the first term, 4 divided by negative 4 is negative 1. So I'm just going to write a negative. The 1 is implied. And then I'm going to divide a squared by a, and I get a. And then I can't forget my x squared that's still there. And then when I move over to the other term, I have 4 divided by negative 4, which is negative 1 again. So again, I'm just going to write minus. A divided by a is just 1. And then I'm left with bx. So c equals negative ax squared minus bx. I'm actually not all that surprised that that's the solution that I came up with. You'll see later, if I were to move over the negative ax squared minus bx over to the other side of the equation, I would have ax squared plus bx plus c equals 0. And that's a quadratic equation. That's exactly the type of equation that you use the quadratic formula to solve. So this solution does make sense to me. It's always good to evaluate whether or not your solution makes sense. The other thing that this opener asks us to do is to take some numbers and substitute them into our formula. So a equals 1, b equals 7, and c equals 10. I'm going to substitute those into the formula that I started with. X equals opposite b. So I need to do opposite of 7 plus or minus the square root of b squared, 7 squared. I like to put that in parentheses because if this were a negative number, it would be really important to have it in parentheses, so it's just a good habit to get into. Minus 4 times a times c. 4 times 1 times 10 all over 2a. A is 1. What I like to do next is I like to take the expression that's under the square root and simplify that first. I can either do that in my head or I can use a calculator, whichever you prefer. For the purposes of doing this right now, I'm just going to do this in my head. 7 squared is 49 minus, and then according to order of operations, I should multiply this first before I subtract it. 4 times 1 times 10 is 40. So 49 minus 40 is 9. So what I'm going to do is I'm going to recopy all of this, -7 plus or minus the square root, but here now I know that this expression simplifies to 9, all over 2 times 1, which simplifies to 2. Now I have a pretty organized expression that I can evaluate. So what I like to do because of the plus or minus is I like to divide this into 2 parts. I like to do -7 plus the square root of 9 over 2 and -7 minus the square root of 9 over 2. That's all that plus or minus really means. At this point, square root of 9 is 3, so this is equivalent to -7 plus 3 over 2. The bottom expression is equivalent to -7 minus 3 all over 2. -7 plus 3 is -4 over 2, which equals -2. -7 minus 3 is -10 over 2. -10 over 2 is -5. I find that whether you're taking the quadratic formula and solving it in terms of one of the variables, or if you're taking the quadratic formula and you're substituting in values for a, b, and c, the key is to make sure that your work is organized, and the more organized you can make your work, then the easier it will be for you to follow. So this is another example of a useful formula. If you can work on mastering, evaluating with this formula now, then when you use it to solve equations with the quadratic formula later in the year, then you'll be an expert.